Okay, here's some more problems from the 2008 AB test, multiple choice. All right, a rumor spreads among a population of n people at a rate proportional to the product of the number of people who have heard the rumor and the number of people who have not heard the rumor. If P denotes the number of people who have heard the rumor, which of the following differential equations could be used to model this situation with respect to T, where K is a positive constant? Now, we have some things called logistic differential equations where we have limiting factors, and some of these look like those. So you have to be real careful because this is tricky. All right? So you have to go back and read it because this is not a logistic differential equation type problem because they don't have a carrying capacity. All right? So you don't know about that anyway if you're in AB, but if you're in BC, it could confuse you. All right? So a rumor spreads amongst a population of n people at a rate proportional to the product of the number of people who have heard the rumor and the number of people who have not. So if you go back to Algebra 2 and you talk about proportionality, all right, if something varies proportional, all right, and we sometimes said something like y equals, and I always told my students in Algebra 2, if you see proportionality, the first thing you write is y equals k. And if it's a product, it could be something like x times z. So we have something like this, okay, because that's what they're saying. A rate proportion to the product of two. A product is two things. So this is the proportionality constant, and this is the product of two things. So you have to have something like that. All right? So when we look over here at our possibilities, this won't fly, but this will, because we've got K, P, and that. So we've got three things. This times this times this. 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 So it looks like three things. All right? So it's a rate proportional to the product. Now we have to figure out what those two things are. Okay? One is it's a rate proportional to the product of the number of people who have heard the rumor. That's P. Denotes the number of people, so it's going to be P times something, and the number of people who have not heard the rumor, so that's P times not P. This is what we use in logic to sometimes refer to not. The little tilde over there. All right, so this is K times P times not P. The people who have heard the rumor and the people who have not heard the rumor, okay? Now, I don't see anything like that over here. So I'm going to have to figure out, well, what's going to go here? So I've got KP times something. So this all looks all right, so I know it's not going to be that, it's not going to be that, so it's going to be one of these two things here. All right? Well, now it looks like they got the number of people and the population, so that makes sense. So let's take a look at this. The number of people who have heard the rumor plus the number of people who have not heard the rumor, that's all the people in the population, and that's the number of people in a population. So you either have heard the rumor or you haven't heard the rumor, so that means you're in the population. All right? So remember, we got KP, so we're looking for not P. So if I solve this for not P, I would subtract P from both sides. So not P equals N minus P. Well, that makes sense. The number of people in the population minus the number of people who have heard the rumor leaves you with the number of people who have not heard the rumor. So that's what I'm looking for. So this is my differential equation that I wrote up here, but not P is the same thing as N minus P, so that's what we've got, and that's letter B. All right. That was kind of challenging. Okay? But you have to kind of figure things out like that, so hopefully that gives you an idea of what you need to do. Okay? All right, number 23. A good old differential equation using separation of variables. I should be experts on that. And like we said before, lots of times those were on the free response, also worth maybe like 7 points. And this is just another one, so this is, and they give you an initial condition, and they even have to figure out the SIGN of the square root. So let's get at it here. dy dx equals x squared over y, so we separate the variables, so the y goes over here with the dy, and the dx goes over here. So we're not going to have a natural log, so we won't have an E-type situation, so that's nice. So these are already out. Okay? So then I take the antiderivative of both sides, so that's going to be y squared over 2, and that's going to be x cubed over 3 plus c. Now's a good time to find what's going on. So I know that y of 3 equals negative 2, so x is 3 and y is negative 2. All right? Now, when I first did this, I kind of mixed this up, and I put the negative 2 there and the 3 there, and I got some really weird answers. And I looked over here, and this didn't look like anything, so I said, I did something wrong. And I realized, I mixed these up. So sometimes, you know, if you get something that looks really strange, look over your answers, and then if you just say, hey, well, that's not going to happen, then look over and say, oh, I did something wrong, where did I do it? So I went back and I said, oh, I did this, I mixed these up. So this works out a lot nicer when you put the numbers in the right order. Okay, so y squared is negative 2 squared, that's 4. X cubed is 3 cubed, which is 27. And then plus c. So all I'm going to do is solve for the c. So 4 divided by 2 is 2. 27 divided by 3 is 9. Okay? And then if I subtract 9, I get c equals negative 7. So this was my equation there. Now I need to solve that for y. So what I do is, first of all, I multiply everything by 2 to get rid of the bottom part there. And then I've got 2/3 x cubed, and then 2 times 7 is 14. And then I take the square root of both sides. I get y equals plus or minus the square root of 2/3 x cubed minus 14. Now, what is it, positive or negative? Well, I look over here, my answer's got both of them, the positive or the negative, so I have to make that determination. Well, I know that y equals negative 2 when x equals 3. Well, the only way that the square root can be negative is if the sign in front is negative, because I'm not going to get a negative out of a square root. So it has to be negative. So it's the negative square root, so it was letter E. All right? So think about these. These are fairly challenging. Okay, number 21, a good old tangent line problem. So, and a linearization and a tangent line estimation. So f is a twice differentiable function, so f of 2 equals 1, so that's a 0.21 that's on the curve. F prime of 2 equals 4, and f double prime of 2 equals 3. What is the value of the approximation of f of 1.9 using the tangent line to the graph at x equals 2? All right. Well, if at x equals 2, I'm looking for the point of tangency first because I need the point and the slope. Well, at x equals 2, f of 2 equals 1, so y equals 1, so the point 21 is the point of tangency. So I need the slope, so I need f prime of 2, and f prime of 2 is 4, so my slope is 4. So there's my equation of the tangent line. Y minus y1 equals m, 4 times x minus x1. All right, so far so good. Then we solve this for y, so that's going to be 4x minus 8 plus 1, or 4x minus 7, and that's my linearization, or my approximation that I can use. So all I have to do is put my 1.9 in there, and I get what I'm looking for. So L of 1.9 equals 4 times 1.9 minus 0.7. Well, that's going to be just basically 7.6 minus 7 is just 0.6. Okay, now just in case they could ask you this, so would this be an over or underestimate of the actual value? They might ask you that. Well, they gave you the second derivative, so the second derivative is 3, which is positive, so that means it's concave up. Well, remember, if my curve is concave up and my tangent line is going to go like this would be my tangent approximation, this would be the actual value, so it would be below, so it's an underestimate. So they might ask you the whole thing. They may just ask you, if you did put the approximation, would it be an overestimate or an underestimate? So you'd have to know that use the concavity over here. Okay? All right, so that's number 24. Here's number 25. There it is, 25. 28. Oh, there it is, sorry. So these aren't necessarily using a calculator, but they get a little tricky. Oh, these are non-calculator problems. Excuse me, I got ahead of myself. So these are non-calculator problems, but they're near the end, so they start to get a little tricky. Okay, let f be a function defined above where c and d are constants. If f is differentiable at x equals 2, what is the value of c plus d? Okay, so now remember this. Differentiability implies continuity, so we know it's continuous. If it's continuous, there won't be any little holes here. So the vertical position here will be equal to the vertical position here at 2. All right? So since it's continuous at x equals 2, we know that this value will be the same as that value. So cx plus d will equal x squared minus cx. At x equals 2, those will be the same value. Well, I can put 2 in for x, so I got 2c plus d equals x squared, or 2 squared, minus xc, or cx, which is 2c. All right? Okay. So far, so good. And then I can simplify this. I got 4, and then if I add 2c to both sides, I get 4c plus d equals 4, or d equals 4 minus 4c. Now, if it's differentiable, okay, at that point, that means that the derivative at both values will be the same. Otherwise, we would have a corner or sharp turn. Pardon me. Okay? All right, in other words, if the derivative from the left wasn't equal to the derivative from the right, the slopes weren't the same, we'd have a corner or some kind of turn. In other words, if this is my 2, and this is one function, and this is the other function, if those slopes aren't the same, I've got a corner. So they've got to be the same for it to be differentiable. So that means the derivative from the left equals the derivative from the right. So if I take the derivative of cx plus d, well, the d is 0, and that's just c. I take the derivative of x squared minus cx, I get 2x minus c. Well, if I add c to both sides, I get 2c equals 2 times 2x, but 2, this is at x equals 2, so that's 2c equals 4, so c equals 2. So if c equals 2, what does d equal? Well, we said over here d equals 4 minus 4c. So 4 minus 4 times 2 is 4 minus 8, or negative 4. So that's what d was. So c is 2, d is negative 4. They ask you what's the value of c plus d. So 2 plus negative 4 is negative 2. B. So you might want to think about that one. Now try to make sure you understand these, because this is what you're going to need to do come Wednesday. Okay?